Okay, so welcome back. I did try to break today's math up into a couple of videos just because it's kind of a lot and I don't want you sitting at one time for more than 15 minutes or so. So it's okay to go to the restroom, get a drink, clear your brain and come back. So hopefully you got your notebook out. Again, we're not going to copy it exactly like this. There's just I have some different ways that I want you to copy it into your notebook. So you've got your math spiral out. Of course, I did forget to add the page number. Oops, what in the world am I writing? I don't know. And what is today? No, it's the 31st. Well, it's the 30th for me, but when y'all are doing this, it's the 31st because I'm doing this on Monday. Not really, just pretend it's really Tuesday. Anyway, so, okay. So you can choose whatever three colors you want. I just made terms green, coefficients blue, and like terms yellow. Not yellow. I'm so tired. It's okay. Like terms pink. You can choose whatever colors you want. Okay. So the first thing we're going to do is write a definition for terms. Okay. And basically, and it is in your paper book, but we're gonna write it on here. It's parts of an expression. Parts of an expression that are separated by plus or minus signs. Okay, so they're part of an expression that are separated by. So we've been talking about expressions, but what we haven't talked about is an expression can either just be something, it's a combination of terms. An expression can just be one term, like 3x, or it can be 3x plus 1, which would make it two terms. It's two different parts, and they are kind of connected or separated by a plus sign. So we're going to write an example of that, and this is where the colors are going to come in. So since I chose green as my terms, I'm going to get my green marker out, and I'm going to write 12 and then plus. So I'm only doing my terms in green. I want to leave the operation signs in. Oh my goodness, I'm a mess. In black. So 3y squared plus 4x plus 2y squared plus 4. And I could put a minus sign in there, it really doesn't matter. So all of the terms are what I wrote in green, and I'm going to underline them as well. So the terms are basically each part of this big, long expression, and the terms are separated by an addition sign. It could be a subtraction sign, but that is what a term is. A term's not just a number. It's not just a variable. It can be a number. It can be just a variable, or it can be a combination of a number and a variable. So it can be 4 all by itself, or it could be 4x. It could be 12 by itself, or it could just be 12, or it could be 12x, or it could just be an x by itself. But it's just parts of the expression, and they're separated. Okay, so those are terms. Okay, so now we're going to add coefficients. What are those? Okay, coefficients are numbers that are multiplied by at least one variable. By at least one variable. Okay, so I'm going to switch to my blue marker because that's what I chose for coefficients, whatever you choose. And I'm going to write the same expression that I did up here, but this time I'm going to write all the coefficients in blue. Now remember, coefficients are numbers. They're not variables. They're numbers that are multiplied by at least one variable. So on this first one, 12 is a number. But it's not being multiplied by one variable. It's by itself. So it's not a coefficient. It's just a number. Because remember, it's numbers that are multiplied by at least one variable. Okay, plus. Now I'm going to make my 3 blue. And I'm going to put my y squared as black. Because the coefficient is the number 3 and it's being multiplied by at least one variable. It's being multiplied by the variable y squared. So this is the coefficient, just 3. Okay, so let's look at the next one, 4x. What do you think the coefficient in 4x? If you guessed 4, you're correct. Okay, only the 4 is the coefficient. Okay, because it is the number that is being multiplied by at least one variable, x. Okay, what's the next one? 2y squared. What do you think is going to be blue? Hopefully you said the 2. 2y squared, because it's the number that's being multiplied by a variable. And then the last part is the 4. Do I make the 4 blue? It is a number, but is it being multiplied by at least one variable? No. So it's just going to be in my black pen. So my coefficients are just 3, 4, and 2 in this example. My terms are all of these, each piece together just divided by the plus sign. The coefficients are just only the numbers that are being multiplied by at least one variable. So that's just these 3. These numbers are not being multiplied by anything. They're by themselves. And then the last part is like terms. What are like terms? Okay, those are terms with the same variables. I have to learn to talk slower. I'm sorry. Raised to the same power. And I'm actually going to, pink is my color that I chose. I'm going to underline same variables and same power, because actually I'm going to box it in because it's so important, these things. Same variables, same power. That is so important. So important. Okay? Same variables, same power. Because we see x's and we start to try to like combine them, and you're like, no, no, no. It has to be the same variable to the same power. So it'll make more sense here in just a second. So let's rewrite this whole expression one more time, but this time we're going to do the like terms in pink. Well, actually, we're going to have to use different colors. That's okay. All right, so let's start with, I'm going to start making 12 pink. This you have to use different colors for each one because there's going to be different like terms, so we have to keep them separated. Actually, I'll start with 12 being, I'm going to start with 12 being green, kind of by itself. So 12 is all by itself as a number, so it's just going to be green. Okay, just kind of follow along with me. 3y squared, I'm going to make that be, I'm going to bring in another color. I'm going to bring in purple. 3y squared. Oh, my purple's dying. That's okay. You don't have to bring in a different color. You can use any one of yours. And then, let's see here. What's next? 4x. Let's go to blue. 4x. Okay, so far none of these are terms that have the same variables, right? This doesn't have a variable. This has a variable of y. This has a variable of x. And so they're all 3 different colors because none of them are terms with the same variable, let alone raised to the same power. They don't even have the same variable. So what's our next one? 2y squared. Wait a minute, I have another y squared, don't I? This is a y squared, and this is a y squared. I'm going to make those the same color. It's this kind of purpley pink color that's kind of dying on me. Make it 2y squared. And then the last one, the number 4, what color do you think I should make that according to the colors that I've been using? Okay, it's just a number all by itself, so it's just going to be green like the 12. So these are like terms. They're just numbers, so I can add them. You can add 12 and 4, right? Okay, these are like terms because they both are terms with the same variable, y, right, raised to the same power of 2, right? They both are y to the second power, y to the second power. If this was just y by itself, they would not be like terms. If this was y to the third power, they would not be like terms. They have to be raised to the same power. And then 4x doesn't have any buddies, but it's just if there was another number multiplied by just x by itself, then it would be a like term with 4. So, but I guess I can go ahead and put a blue line underneath it. Okay, so why bother doing all of this? Okay, so when you're given expressions like this, these big, long expressions, you're usually going to be told to simplify it. And as I said in the previous video, when we were trying to figure out if the expressions were equivalent, when you're asked to simplify it, it's like do everything you can possibly do until you can't do anything else. Just like simplifying a fraction. Can you make it smaller? Can you make it smaller? Can you make it smaller? Well, can you combine things that are the same? Because we actually can do that, which is pretty cool. We can actually combine if they are like terms. They have to be like terms. So because we have the commutative property that we know about and we can rearrange things, the first thing I want to do is I want to rearrange, they're all addition. Commutative property addition tells me I can rearrange all these guys. So I'm going to put all the things that are alike, like terms, next to each other. And I'm just going to use a pencil here. I'm going to take my 12 plus 4. I'm going to move the 4 down here by the 12. Okay. Scooch this up a bit. Okay. And then I'm going to put my 3y squared next to my 2y squared because they're the same, right? And then I'm just going to tack my 4x to the end. And then because what I know about the associative property, I can go, okay, I'm going to take care of adding these because I can combine those, so just 2 numbers. Then I'm going to add these 2 together because they are like terms. They both have the same variable y raised to the same power of 2. And then 4 is just kind of on its own. So then once I do that, I can go ahead and add 12 plus 4 is 16. Plus, now you can add these. This is new to us. If I have 3y squared and I have 2y squared, I can add them together. Kind of think of them as like objects, like if y squared was like a little tile. And they do have algebra tiles, but I usually bring those out in class, but we can't really do that. But that's okay. But you can just, if y squared was like a little, yellow tile that said y squared on it, and I had 3 of them, then I had 3 little yellow tiles that all said y squared, and then I had 2 more little yellow tiles that said y squared. How many little yellow tiles do I have of y squared? I have 5. Okay, so I can just add my coefficients. Now I have 5y squared plus 4x. 4x doesn't have anything I can, and that is the simplified version of this big long expression. I can't do anything else to it until somebody says, well, what if x is 2 and y is 3? Then I could insert those numbers in like you guys were doing a couple of weeks ago and solving. Okay, so that is how you can take that. This vocabulary is super important, and I hope that if you did it in the colors like I asked you to, you'll be able to come back to these and go, okay, now wait, what was that coefficient again? It's just the number in front of the variable. Okay, you can add the coefficients if you have like terms. And what are like terms? A number, okay, or a term that has the same variable raised to the same power. So I was able to add my 3y squared and 2y squared because they were like terms, and I was able to just go add my coefficients, which is pretty cool. So what I want you to do is I want you to pull out your book. It should still be there. And flip over to your turn on the next page. So the definitions were on 311. If you flip over to, you know what, it's going to fall off my table. I'll just switch my camera. That book's falling off the edge of my dining room table. There we go. Okay, and I want you to combine the like terms on 8 through 11. So take a second, pause the video, combine them on 8 through 11, and then turn it back on when you're ready. One thing to note is, ooh, look, I might need to take care of the distributive property there before I can combine anything. And I know they worked a bunch on this page over here, but I really don't like the steps they used. I think they're super confusing. So if you want to look at those, great, but I think they just added even more steps than you actually need. And I know how much you guys love showing all the steps. So I'm giving you a way to show less steps. I know that's hard to believe. Don't get shocked. Okay, so pause for a second and then come back and let's see how you did on those. Okay, how'd you do on these 4? So are these like terms? Yes, they both have the same variable y, and they're raised to the same exponent of 1. There's just one of them. So I can actually take my coefficients 8 and 3 and just subtract 3 from 8. Again, imagine them as little tiles, little yellow tiles that have y's on them. I had 8 of them and I take 3 away. Well, I have 5y left. Oh, my pencil's not very dark. Okay, so hopefully you got 5y on that one. Now this one's kind of cool because you've got to do a little distributive property first. You kind of take that 4 and kind of pour it inside these parentheses. I like to use the word pour. I don't think I used it last week, but I'm going to multiply each number inside that parentheses by the 4. So I'm going to rewrite it up here because I just like to have some space. Plus 4 times x squared is 4x squared, right? Minus, because there's a minus sign there, 4 times 1 is 4, right? Okay, but am I done? Or can I combine some like terms? Well, I have an x squared here and an x squared here. They are both the same variable raised to the same power. I have 6 of them. I get 4 more of them. So now I have 10x squared minus 4. Just be really careful you don't forget to bring that sign up here and keep this sign right here. Okay, so you should have gotten 10x minus 4, 5y. Okay, what are my like terms here? I see some a squares. I should be able to combine those, right? And I see some b's. And remember on the homework that you guys did on Friday and Monday, and there was just like a negative x, and you guys were like, hey, what's the number? Well, remember we said there was like an invisible 1? Same thing here. This is like an invisible 1. If you have a variable by itself, there's just an invisible 1 in front of it. So if I have 4 A5s, imagine they're little squares or tiles, and I take away 2 of them, excuse me, then I just have 2 a to the 5th power left because I combine these two. The associative property, you are allowed to put parentheses around things because of the associative property. I'm going to put the two, these like terms together. And these, they've already have these arranged like the commutative property with the like terms by each other, but you can rewrite them and put them all together so that you can group them using the associative property and make sure you don't make any mistakes. So these are already next to each other in the right order. I have 4b and then I get 1 more b, so I have 5b. So hopefully you got that one. Okay, and then this last one, let's see, I have an 8m. Are there any other m's? Nope. I have a 4n. Are there any other n's? Nope. But can I associate these two with each other since they're just 2 numbers? Sure. So I can just rewrite this as 8m, and I can go ahead and do the 14 minus 12. Keep that plus sign. Plus 2. Keep this plus sign. Plus 4n. And that is the simplified version of that one. So, that is combining like terms. That's one of my favorite things. You're distributing, and you might need to rearrange some things. I'm just going to tell you that my students who like to not rearrange things and save steps, here I am making you write out more steps again, sometimes make a lot of mistakes here. So don't be afraid in the beginning until you get really good at these to go ahead and rearrange them if you need to. Use that commutative property to put all the like terms together and put little parentheses around them and associate them. Just be really careful to keep your plus and negative signs together. So the last thing, I'm going to go ahead and end this video, but I want you to, okay, we're not going to look at this guided practice right now. I want you to look over at this page, and I want you to scoot down to the bottom here, right here, these combined like, you know what, I won't end this video. It's silly, because you can just pause it and make it like another video. So I want you to pause the video, and let's just do, there's a lot of them here. Let's just do, those are too easy. Let's do these 6 right here, okay? The first 4 are too easy. Okay, so let's do these 6. I'm going to scoot this up so you can see the page, okay? If you want to go back and do those 4, you can. But let's do those 6, pause it, and do those 6, and then we'll wrap up math for the day. There's a couple of, there's 10 practice problems for you to do that you'll do online, and then you'll do some more of this tomorrow. So pause, solve these, and then come back. Okay, final check. We have 6 problems to check. We're combining like terms. Let's see here. I've got this right here, again, is my clue right away. I got to take care of some distributive property. I've got one number out in front of a parentheses that has 2 terms inside, and I've got to distribute these out. So this is a little tricky because there's not a lot of space to write your work. So I'm going to it's going to be a little squishy, so y'all bear with me. If you solve these on notebook paper, that's fine too. So if I have y plus 4 plus 3y, 3 times 2 is 6 plus 6, is that its simplest form? Hopefully you said no. Because what can I combine? I can combine my y and my 3y. This is going to get squishy. I don't like this. And I get 4y, right? And I can combine my 4 and my 6 and get a 10. Okay, so my final answer there is 4y plus 10. Okay, let's look at this next one. This one doesn't have it won't be as squishy unless it's got the distributive property, which of course I picked ones with the distributive property. Yay. Okay, are these like terms? Yes, because they're both a's as the variable and they're both to the second power. So they're 7a, take away one of those 7a's. So this gives me 6a squared plus 16. Can I do anything else? No, I can't do anything else. So that one is all simplified. This one, because it's kind of squishy, I'm going to write it down here. I've got space. I'm not going to work this one. So I'm going to write it down here. 4y squared minus 2. Okay, so the first thing I'm going to do is go ahead and write my 3y squared plus 3 times 4y. Well, you're going to multiply your coefficients together, or 3 by that coefficient there. 3 times 4 is 12, and you keep your y squared. Okay, so I multiplied it there, and then I'm going to take my 3 and multiply it by my 2, minus 3 times 2 is 6. Okay, now can I combine my y squares? Yes, 3y squared plus 12y squared gives me 15y squared minus 6. So if you did not get 15y squared minus 6, you might want to see what you may have done wrong. Okay, so this one was 15y squared minus 6. Okay, this one doesn't have the distributive property, so I can work it. Let's see. That's z to the second power. This has z to the second power. That's z by itself, and that's z to the third. Woo! Okay. I'll start with my z squares. Actually, usually when you're writing, combining like terms, you usually put the term, the variable with the largest exponent first, and then the next smallest exponent, and then the next smallest. So let me kind of explain. Out of the, let me zoom in a little bit. These numbers are really small. Oh, it's much better. Better for my eyes too. Out of these variables, which one has the highest power? Well, this one is to the third. There's nothing else to combine it with, so I'm actually going to start with 4z cubed to the third. Okay, if you didn't have them in this order, you can rearrange them because of the commutative property, right? So now I'm going to look at my squares. I have z squared, it's got an invisible 1, and 4z squared, right? So I have 4z squares, and then I have 1 more z squared. So I have 5z squared. Okay, plus 1z that's all by itself. So notice how I started with the variable that had the largest exponent, and then I went to the variable with the next largest, and then the variable with the smallest. So this is really proper, it's good form in algebraic expressions, but it's not wrong if you have it in a different order because the commutative property of addition says it's equivalent, so you're good. I'm going to take this one over here and write it down there where I have more room. 0.5 x to the 4th power minus 3 plus 12. Okay, so I've got to distribute this 0.5 into each number. And, oops, sorry, I'm getting into my picture. So I'm going to do, this is a 1. Remember, there's a little invisible 1 here, right? So 0.5 times 1 is just 0.5x. Oop, to the 4th power. Sorry, almost forgot my exponent. Minus, if I have a 3 and I'm multiplying it by 0.5, which is half, then I'm going to have 1.5. Right? Let's see. Where's my... Oh, I didn't do this one yet. Plus 12. Okay, so I distributed my 0.5 times 1 is just 0.5, doesn't change, x to the 4th. And then my 0.5 times 3 is going to cut my 3 in half, okay? And then I still have my plus 12. Now, I don't have any other like terms to combine. I still have my 0.5 x to the 4th, but these are both just numbers. Can I combine them? Yes. Now, here's the tricky part. Okay, I'm going to get my red pen. See this minus sign in front of it? You kind of have, in order to combine numbers, you have to look at the sign in front of it. I know we've not really talked about this. Well, did we? Yeah, we did back when we were adding and subtracting positive and negative numbers, but it's been a while. If you're just adding and subtracting a bunch of positive and negative numbers, you need to look at the sign that's in front of it, because the sign that's in front of it is basically telling you if it's a positive or negative number. So since this is a negative 1.5 and a 12, you're basically taking your 12 and taking away 1.5. So if I took away 1, I'd have 11. Why am I putting an equal sign there? Sorry, should be a plus sign. If I take away 1, it gives me 11. If I take away half of that, it gives me 10.5. So this one ends up being 0.5 x to the 4th plus 10.5. Okay? And then the last one, and then we are done for the videos, is I'm going to go ahead and multiply 1/4 by each thing inside the parentheses. 1/4 times 16 gives me 4, plus 1/6, that just gives me 1. Oop. But I don't have, I can say 1p, or I can just put a p there. I don't even really need the 1. And so that's it. It's just 4 plus p. There's nothing else that I can do. Okay, I don't have to combine anything. Okay, so that was kind of a lot, and the problems are a little complicated. Yeah, tomorrow I might encourage you to watch Dr. Berger. He's pretty funny. But you can always come back and listen to this. But sometimes Dr. Berger just is really good at explaining it a different way too. So hope all this makes sense. It's complicated stuff, and the practice problems, there's a couple of tricky ones, trying to see how well you guys are getting this. Don't stress over the practice problems. It's not for a grade. It's just a completion grade. But when you click the button that you're done, I'll automatically see. I think you should get your grade so you'll know how you did, but don't stress over it. Okay, I think that's all I've got for today. So you guys, let me know if you have any questions. All right, bye.